Hi everyone, I'm Pete Warden, and I'm here to show you how you can use the new Moonshine voice library to build voice interfaces that are super fast and super accurate on your Raspberry Pi. So the first place to get started for all Moonshine questions is on the Moonshine GitHub. So that's at github/moonshine-ai/moonshine. And you'll see we have a monster README. But the part you want is quick start. And then if you scroll down, you'll see we've actually got a Raspberry Pi section. And because we distribute our stuff as a standalone Python pip package, you can just use pip to install it and start using it. So I have a Raspberry Pi 500 here that I've plugged in just a standard USB microphone so we can get some audio input. And really that's all you need. A Pi and a microphone. I'm using a Raspberry Pi 5. We're able to run on older Pis, but obviously the performance is going to be better on the Pi 5 because it's nice and fast. So we have an example that you can download from this link here. Now, I'm actually going to be SSHing in to this Pi 500 from my laptop. So if I just switch over, I've already SSH'd in here. I'm actually going to start up a terminal, and because I'm doing this through the command line, you can always just go to Chromium on your Pi and download the example directly using the GUI. But because I'm SSH'd in, I'm going to use curl to download that link instead. So just go here, make sure we have the URL right, and give it a second. It's pretty small. It's just a Python script, so it's about 3 kilobytes. So now I'm gonna run the tar command to extract the .tar.gz that we have here, and extract file, just remembering the flags there, and then I've got this Raspberry Pi examples. Now, the first example is actually a program that listens out for particular actions and triggers when it hears something that has the same meaning as the action. If that doesn't make sense, don't worry. I'm going to start off by just showing you the transcription. But to do that, I'm actually going to use Visual Studio to actually open the folder. So it's in Pete. I just go to, it's called My Dalek. I hope that the BBC does not go after me for this. But I'm willing to take that risk. I've gone to that directory in Visual Studio. Now I'm going to open up the terminal, and because on the Raspberry Pi, if I just try pip install moonshine-voice, it ends up giving me a scary error about the environment being externally managed. I can actually work around this by adding the break system packages switch, which is extremely scarily named. Instead, what I'm actually going to do, I kind of like the new UV virtual environment utility that makes it easier than a lot of older Python virtual environment systems to just install packages locally. So I'm going to use the command that's listed in the README to download and install it. Then I'm going to create a virtual environment. And none of this stuff is really to do with Moonshine Voice. It's just kind of Python package hygiene. So don't worry if this doesn't make sense. You don't really need to understand it. Just install the Moonshine Voice pip package however you prefer. It should work with all of the systems out there as well as UV. But in this case, I'm going to use UV to install it, and went pretty fast. And now I'm actually going to go back to the documentation so I can show you the one-liner that you can use to run a microphone transcriber without writing a line of Python code, just using some of the built-in utilities that Moonshine Voice installs. So I've copied and pasted that. What this is doing is it's saying, hey, use the mic transcriber module from Moonshine Voice, listen out in English, and it's going to print what it hears to the terminal as I'm talking. So let's give this a try and see how well it does. Hello, this is Pete. How are you doing? Let's try something a little bit more complicated. So far it seems to be doing really well. I'll keep pushing it just to make sure that I can actually get it to make a mistake. And so far it seems to be doing pretty well. But as with all automatic speech recognition, I'm sure you're going to be able to break it. There's no such thing as 100% accuracy. But you can see this is actually pretty good. And it seems to be running pretty fast too. Okay, so enough messing around with that. But hopefully that gives you the a starting point where you can see that it's actually able to recognize speech pretty fast and without having to do too much setup. When you run it, because I've already run this once, it hasn't downloaded any models because they were in the cache. You'll see it downloading a couple of 100 megabytes worth of models. But other than that, everything is running completely locally. You don't need any kind of connection to the cloud to run this. And you can also use it for more than just capturing speech. So this is where dialects come in. So what this example is doing, and I'll actually bring up the code here so we can look through it. In Python, you're pulling in, get rid of those warnings. We're actually pulling in the bits you need from the Moonshine Voice library. And we've got a few arguments. Oh, and this is Fiona, my sweet little girl, who's extremely concerned that it's an hour and a half before dinner time and we haven't fed her. But she is an excellent programming companion, and I'm glad she popped in. So dogs aside, you can see that we pass in a few arguments that you don't have to really care about. And then we actually have what's called a transcript event listener. And this is the way that we provide updates when live speech is happening through the Moonshine voice library. So you can see there's these like online started, online text changed, online completed. They get called as soon as something happens on the microphone. So to do this intent recognition program, we actually start off with the transcription model first. And then the second thing we need is a sentence embedding model for intent recognition. And if you're used to things like Siri and Alexa and some of the older interfaces, you'll know that you have to phrase your requests in a very particular way. You might be able to say, turn on living room lights, and it'll understand you. But if you say, light up the living room, it may not. And obviously these are improving all the time. But one of the great things that LLMs has brought us is the ability to do fuzzy semantic matching. So matching sentences by their meanings. So in this case, this is the prototype for a robot that you have voice control over, and you want to be able to do the usual, things with the robot, have it move around, have it kind of, destroy humanity. So each of these functions is called when one of those requests is detected. And you can see we have this dictionary where we register, hey, here are the sentences that I want to fuzzily match. So in this case, move forward should also match with go ahead, advance, and other things that mean the same thing. And the same for all of these. And you can even add multiple sentences to trigger the same action. For you really want to make sure that you're certain when you're, destroying humanity. So I've added both kill all humans and exterminate here. You've created this intent recognizer object. You register the intents. We just print that out here. And then all we do is start up the transcriber. When the transcriber finds a complete sentence, it passes it to the intent recognizer. And then the intent recognizer does the fuzzy matching to be able to tell if it's actually something that the robot should take action on. So, with all that said, let's actually give this a try and see how well it works. Make me a ham sandwich. Destroy humanity. Go forward. Move to the left. Go into reverse. Yes, you do make me a sandwich. So you can see here that when I'm just talking normally, it's not detecting those as actions. Because they don't match any of those intents that we've got. But if I do say something that matches, like go to the left, then it actually picks that up as one of the commands it's looking for. So that's a really simple voice interface that you can build. You can see here it's a pretty short Python program. You can obviously look at modifying these phrases and these actions to whatever you'd like. We've had people doing everything from controlling equipment to even putting in hundreds of frequently asked questions and having the device respond with pre-vetted answers. So that's another great thing you can do beyond command recognition, is actually have a little question answering assistant. So I hope this gives you something to get started with. I love my Raspberry Pis, and it's been really fun to be able to put something together like this that lets me think about all sorts of fun projects that use voice as an interface. So I hope you find some interesting and worthwhile stuff to work on with this. Do let us know. We love to hear from you. We have a Discord, which I'll link to below. And have fun.